Hello friends, my name is Akshay. Today I will solve the today's Geeks for Geeks daily practice problem. Okay, so our problem is here. Statement is given, which is a given binary tree and a budget. So this means that we have to given one binary tree and one thing is another budget. Okay, and assume you are at a root of the tree. Okay, so it tells us that assuming we are starting from the root of the tree. Okay, and then you need to maximize the count of leaf nodes you can visit in your budget. Okay, so we have to find maximum number of nodes. Which node? It is must be a leaf node. Okay, and we have to reach all maximum count of leaf node with our budget, and budget is given. Okay, so if the cost of visiting a leaf node is equal to the level of the leaf node, okay, and it say us that the cost of the visiting leaf node it is its level. Okay, so here tree is given and budget is 8. Okay, so how many leaf nodes are there? So here 1, 2 and 3. 3 leaf nodes are present in our tree. So the level of the reaching this leaf node is 1, 2 and 3. So the level is 3, so budget is 3. For 6 budget also 3 because 1, 2 and 3. 6 is at 3 level of the tree and 4 is the level of 4. 1, 2, 3, 4. Okay, so we find maximum node, so it means the level of leaf will be minimum. So we take first nodes which have minimum level. So 3 and 6 have minimum level. So for reaching 3 we have to budget of 3, and for reaching 6 we take budget of 3. Okay, so 3 plus 3 is 6, but if we included 4, so the budget will be 3 and 3 and 4 is 10, but our given budget is 8, so we can visit only 2 node. So here output is 2. Okay, see the next test case. Okay, so this tree is given and we are starting at root. Okay, and our budget is 5 for reaching node. Okay, so here we can see that all node have budget 1 and 2. Okay, 1 and 2 budgets. No, not 1, 2, 1, 2 and 3, because 4 is the level of 3 at a tree, and 5 also at level 3, 6 at level 3 and 7 is at level 3. Okay, so for reaching 4 we spend our 3 on the given budget, so the budget is only 2, so we cannot reach another leaf node because minimum budget is 3 for reaching another, and we remain only 2 after visiting any leaf node of this. Okay, so we can only visit one leaf node. So let's start the code for this. Okay, so we have to take minimum budget of a leaf node. So we do one thing, that we take a priority queue minim for storing the budget. Okay, so here I write priority queue. We take it inside the function. Integer and let's the name of queue is Q. Okay, capital Q, and we have to travel this, so you can travel anything. I use BFS because BFS can give level. This level is 1, this level is 2, this level is 3, and the level is 4 for this node. We can find levels using BFS. Okay, so take another queue which is only simple queue. Okay, and queue dot, and this we use capital Q for storing levels, okay, and we use small q for helping our BFS traverser. So here we the data type of queue is node. So again in this code you have to need understanding about BFS, how BFS is work. If you don't know, so you cannot understand this this code, okay. So here we write while, but doing before this we have to push root in the queue, and then queue dot not empty. Up to this we have to travel this loop. Queue dot empty is not equal to null, okay, and not equal to 0. So here we have to take one size, q dot size, okay, and we have to find the level. So here we use one variable level which is starting with 1, because here is given the root node is starts from 1. So here I level of root node is 1. Okay, and then here I use for loop for I starting with 1, I less than equal to size, and then I plus plus, okay, and after doing this we level plus up to 1, okay. So here we pop from small q, okay, so node star, here I take one helper q dot front, okay, and then if helper left is null and helpers right is null, so we have, so what is the meaning of this? If helpers left is null, so it will be true, okay, and helpers right is null, okay, so it will be true. So what is meaning when helpers left and right is null? So it means this is leaf node, because leaf nodes all pointers is null, so this meaning this is leaf node, okay. So if this is leaf node, to so we have to push its level in the queue, capital Q, because capital Q we have created for to store the levels of the leaf node, okay. So we store all levels of all leaf node in this priority queue, which is minip, okay. And if helpers left, so here we have to q dot push. This is a part of BFS, as you know, so I am not explaining this. Okay, if helpers left is not null, then it push in the small queue, and helper right is not null, so it will push in the queue, okay. So this is very easy. So here we can store our all leaf nodes level in this queue, capital Q. So we take one, so we have to here again one loop for how many node we have to take, okay. So here we take two variable, which first one is answer and second one is second helper, okay, which is 0. So here I use while loop up to capital Q not empty. Okay, here we pop Q dot nodes capital Q. Okay, so helper take the front value of Q and Q's front which value give. So as you know, capital Q store the level of all leaf node. Okay, and it is minim. So the front will be the minimum level of the leaf node. Okay, and then it taking us in ascending order. Okay, but first of it will give the minimum number of level. Okay, which leaf node have. So helper have minimum level 3. Okay, so here we take one if condition. If second helper plus helper is more than k, so we break this. Okay, else second helper plus equal to helper. Okay, and ans is plus plus. If second helper plus helper is more than k, k is a given budget, and our second helper and helper is more than budget, so we break this. Otherwise our second helper plus the helper. Okay, so if we visit this leaf node, okay, so the level of this node is 3, so our from 8 we spend 3, so 5 is remaining. So like this you can understand. So first of all our second helper is 0 and our second helper plus helper. Okay, so helper is 3 and second helper is 0, so 0 plus 3, is it more than k, which k is 8, so no, so it will be false. And then second helper, in second helpers you have adding this the level of this leaf. Okay, the budget for visiting this leaf node in second helper. So second helper plus plus, and we visit one leaf node, so here ans is plus plus. Okay, and then visit this another leaf node which have minimum cost. So here we check second helper is right now 3 plus 3 is 6, is 6 is more than 8, so no, the loop will be false. And then second helper also adding this cost again, this code. Okay, so second helper have total cost for reaching 3 and 6. Okay, and then again loop will run, and then helper has at this time 4. Okay, and here check 4 plus 6, second helper has 6, helper has 4, so 4 plus 6 is 10, and 10 is more than 8. Yes, so here statement is break, and ans will not plus plus, so our answer is ans. And then at the end here you have to return ans. So just run the code. Okay, what is error? Yes, queue has no any front function. Priority queue have function name is top, not front. Okay, okay, it give us time limit. Okay, TLE, please optimize your code. So okay, our code is clear, so we have to optimize this code. For optimizing this code, here we write is equal to null, and here equal to null. Okay, push here, then level plus plus answer, second answer, while q not empty, helper is equal to q dot top. If second helper is correct, then compile this code. again it shows me time limit. Okay, so how can handle this? Okay, let's try which thing we can minimize. Yes, here we forget the popping this q dot pop, and here we also forget pop this q dot pop. Okay, and then compile the code. Okay, so our output is same as the expected output, so submit this code. Okay, so our all test cases passed, so here code is completed, and this code is very easiest code, because what have we do in the given code? We have to inserted all level of lift node. Okay, we did not inserted lift nodes in the priority queue. We inserted only levels of this leaf. Okay, and it's inserted in min heap, so it's by default in ascending order. Okay, so first we take the minimum level of the leaf node, and then next and next and next we take into this capital Q. Okay, so code is very easy, and thanks for watching my code, and please like, subscribe my channel, so I will be doing this video more and more, this type of videos. Okay, so bye.